Okay, welcome back, guys. Okay. Okay, so during the break, well, amongst other things, I was trying to figure out if I could fix the microphone on the computer, but that did not work out, unfortunately. So, but what I am going to show you here is, again, I've downloaded Champ. That's how I'm told you should respond. You should pronounce the name of this product. So you go, it's under this ApacheFriends.org website. I was hoping it would be done installing by the time that we got back, but it looks like it just, okay. So it has finished just installing it. Okay. So basically, when you download this, if you're like for me running a Windows machine on this, what I downloaded was the executable installer. And then I just ran that executable and it's going to ask you, do you want to start the control panel? So yeah, so I want to go ahead and start that. So let's hope that this works because I have had it happen where it doesn't like to work the first time. Okay, so this is what you should see when you start the Champ control panel. This is what I am going to be working with for this semester. Okay. The main things that we need to deal with are these two, the Apache server. We're going to start it. And then we are also going to start the MySQL server as well. Okay. So on this computer, I appear to have gotten some type of security problem. So what I'm going to do is I'm going to allow access for it to do what it needs to do. Okay. So now this should work. If I'm not mistaken, this I should be able to now go to localhost. Is it this one? Is it the 88? No. Can maybe try without the port number. Yeah, there it is. Okay.
Which version will we use in this lecture?
So I'm using what I downloaded here was the most recent, which it was the 8.2 version of Champ. The older versions, I think I've I've taught this class for a number of years, so I mean, even if you go back to versions that are 2-3 years old, you should still be able to use those. Okay. So when you get into localhost phpMyAdmin, you go into the MySQL. Actually, what I'm going to do now is I'm going to create a new database. I'm going to call it CSE204 2023. Okay. And then in here during the semester is we will create tables. You'll learn all about what tables are and columns and rows in tables and stuff. So, but most of my examples during the semester, I'm going to put into here, into this CSE204 database. Okay. So this will be, so get familiar with this, with this view here. And what we will do is during this semester, you will see this a lot. Okay. All right. But for now, what I'd like to do is I would like to do a little bit of background and introduction of database in general. So let's see, get this going. Okay. So intro to database systems. Why? Why databases? Why did databases come about? Why do they exist? Why did we not just stick with whatever the old system was? What benefit do they bring now that we what benefit do they bring now that we didn't have before? Okay. So we'll talk about some of this set of slides. This is some of the objectives of what we're going to be trying to talk about. It's kind of a bird's eye view. It's an overview of the database management system, a little bit of history, and of course, advantages and disadvantages. You guys know I like to talk about trade-offs. I like to talk about how uh, why some things are better than others in certain situations. Okay. So here's some examples of ways that places we might see a database, right? So supermarket. So when you go to the Migros or the A101 or Shoke or Beam or wherever you go, right, there's going to be a database there. Like when they scan the item, right? When they scan the barcode, right? It's accessing a database of the products that are in that supermarket and in its inventory. Uh, when you get a credit card statement, there's going to be a database behind that. Your bank account, if you have one, if you have a bank account, there's a database that stores all the information and the transactions and all things like that. Right? Uh, OBS has a database. Right? So as we're studying at a university, OBS has a database behind it. If you've watched a video or a movie on Netflix or Disney Plus or any of those sites, right? Or YouTube, if you watched a video on YouTube, all of those have a database behind them, so they're not just standalone websites, right, or web pages. So databases are used everywhere. Microsoft Teams. We're using a Microsoft product, Microsoft Office. All of those things are going to have a database behind them. Okay. So those are just examples of where we see databases in action all the time. So what did we have before? So we had like a file-based system before databases existed. Many of you probably remember from 101 when we talked about how to read from files and write to files. All right, so that was basically the way that programs would store and view and manipulate their data from before, okay? From before the existence of databases. So we could generate reports, we could manipulate data all through files that the program defined. Right? One of the drawbacks here was that each program would need to define and manage its own data. So each program would have its own file that it was manipulating and dealing with. So an example, you're going to see this type of information a lot this semester. There's what we might call a case study, which is an example that we can use. We're going to use it all throughout the semester. The textbook refers to it as the dream home example. It's basically a database for managing properties for rent, managing information about their owners, about people who are renting those properties. And so, as you can see, based on the cities, all of those properties are in England. So this is Great Britain. And so I've never been there. So some of these cities, like I'm not sure how to pronounce the name of this city. I need to meet a British person that can tell me how to pronounce their city names. All right. So this might be an example of you might have each of these would be its own file with a line in that file where if you've ever dealt with what's called a CSV file, a comma separated values file, Microsoft Excel can create comma separated values files. Basically what it is each section of text is separated by a comma. So you would have a line that would be PA14, comma, and this other information, comma, and this other information, and so forth, so that it tells you how to separate out the information. Okay. So if we were to look at this as a text file, what we would actually see is each line would be this text with a comma between each value on the line. Okay, some other things right? So what we might see is something like this in an Excel spreadsheet, but then we would save it as a text file, as a CSV, comma separated values file. Okay. So file-based processing might have different parts of the company, different departments in the company. So you might have a part that's particularly interested in the sales, which would be the selling of property from one owner to another. This would be the contracts department, which would be the part of our company that deals with um, renting. All right, when renting the property from one tenant to another. Uh-oh. Okay. I think I'm back. I think I got lost for a second there. Okay. So let's see. So notice that in an older file-based processing system, each department, each system has its own set of files that it deals with. Okay? Now, some of the information in these files is shared, right? So both of them have property information. Now notice that sales files might have a, let's see, some information in its property for rent file that might not exist in the contracts file. That's entirely possible there. Um, the problem, as we'll see, is one of the limitations here is that by each system having to maintain its own files, what happens if information is changed in one, but for some reason is not at the same time changed in the other? We have conflict. We have a conflict in the data there. Okay, that can be a real big problem there. Now, you might think, as some of us did, right? You might think, well, what if we just had like one single set of files out on some shared drive, and uh, like a Google, like a well, back before Google Drive, right? On a shared drive on the network, and we all just access those files. Okay? I don't know if any of you remember the days when that was common, where you would have like a shared drive and you could have like Microsoft Word documents, Excel documents, text documents out in this shared drive. And what would happen is if someone opened a file for editing, no one else could open that file for editing. So if, like, for example, if I had a colleague, a coworker, who had a file opened for editing, like a Microsoft Word file, and if I went to open that same file, it would give me an option to open it as a read-only file. I could open that as just read-only, and that's the only option that was given to me. Okay. Which won't be helpful if I need to change something in the file, right? But that was done so that if one person had it open for editing, I couldn't have two people edit the same file and possibly one overwrite the other's changes. Okay? So what was much more common would be each system would have its own set of files that it was dealing with. Okay, so some of the limitations, quite a few. There are quite a few limitations of this file-based approach, right? One is that each program maintains its own set of data. Okay. Now, there may be one program that doesn't know that another program has its own set of data and it can be used there. Right? Some data is duplicated. So in the example that we just saw, the property for rent was duplicated. Files existed in both of the places. This could result in wasted space, right? Because why do we need to save the same thing more than once? Right? Also, different values or different formats of the same item. So let's say one property is listed as being a certain amount of rent in one system, but it's listed as a different amount of rent in another system. That's a conflict, right? So which one is the right value? So now we got to figure out which one's the right value. That can be a big problem. Okay. So you could have data dependence, right? Where the file structure is defined in the program code. So if the file structure needs to change for some reason, maybe we want to add a new column or a new piece of information, or in one system that I worked on, they needed to change the number, the currency, the maximum currency value from like it was like $1 million up to we needed it to be able to be up to $100 million. So from what is that? 9 if you count after the decimal point, but 9 digits up to 11 digits. Well, we needed to change the file. We needed to change the file structure, which meant that had that been in a file-based system, we'd also have to change the program, the source code itself to be able to understand that new file format. Okay. Programs can be written in different languages, so we might not be able to easily access other files, so files from other systems. Let's see. New requirements might require a new program entirely. Okay. So, as I said, one potential solution was that we have shared files on a shared drive, but as I said earlier, one of the big drawbacks and one of the big problems with that was that only one program, only one user could edit the file at a time. Okay? And that could be a problem. Right? And so what we wanted was we wanted a way to be able to have the data be separate from the program and have the data be stored in such a way that multiple different programs could access the data at the same time. And that would be including viewing the data, as well as changing the data, and as well as the format. Like the format should not matter. What we would like is to be able to have a situation where one program, the format, let's see, the program is not dependent on the data format. Okay. So what we ended up with was the database management system. So get used to this acronym here, DBMS. So pretty much anytime you see the letters DB, anytime you see the letters DB on something, it is probably going to stand for database. So an example we'll look at, we may not get to it today, we might run out of time, but the IMDb. Has anyone ever visited the website for IMDb? And do you know what it stands for? Okay, so I already gave you a hint in what the DB stands for, so you already have half of it, right? Yeah. Close, Kershad. Yep, Merritt. Okay, good. There it is, Merritt. So yeah, it's the Internet Movie Database. So it does store more information than movies, though, as we will see when we look at it probably tomorrow, I'm thinking. But yes, the Internet Movie Database is what it stands for. So if you ever see the letters DB, most likely it stands for database, especially if it comes on the end of something like that, like IMDb. Okay, moving on. So database is basically a shared collection of logically related data, and it can be the description that what we might call the metadata. Okay. We'll talk about things like entities and attributes and relationships of an organization's information. Okay. One thing I will go ahead and say in advance is make sure that you understand that a relationship and a relation are not the same thing. We will talk about how relations are related, or how they have relationships between them. Okay. So this is basically what a database is, but a database management system is different from a database, right? A database management system is going to be something that allows us to access, to define, to create, to maintain the database itself. Okay, so if the database are the structures and the data that's stored, a database management system is how we control it. So if we think of it as, if you think back to 101, right? When we got to that point where we wrote to files and we read from files, and we used file-based a file-based program that you did in 101. The files would be like the database. It's where the data is stored. It's how they're organized. It's the different files that are there. The database management system would be like your wouldn't be your code. Actually, you guys didn't create a database management system type thing there, because it would be the thing that created the files themselves and established the format for the files themselves. So a little bit different. But your code did write to the files. So, and adding, yeah, adding rows, adding data to the file could be part of it too. So, so you did kind of create part of a DBMS, but it was all file based, which again, we're trying to get away from that, right? Okay. Again, one of the things that you'll get used to this semester, you'll learn is this SQL statements or SQL. We'll call them that. Both of those pronunciations work. So SQL is how we deal with the structures of the database as well as the data in those structures. There are things called no SQL databases. I'm hoping that we will have time this semester that we can have at least one lecture discussing no SQL databases, but I'm not positive that we'll get to that. We'll see how the time goes this semester. Okay. So as we see here, now instead of sales and contracts having its own set of files to deal with, we have a database system that interacts with the DBMS, which then interacts with the database itself. Now remember, the database, part of the database is the data that is stored there. The DBMS controls who accesses the data there. So let's say there's something that contracts needs to be able to have access to, but sales does not. We don't rely on the program itself to determine that. We can rely on the DBMS to allow or reject access to certain data and certain parts of the database to certain programs and certain users even. Okay, so we rely on the database management system not only for controlling and manipulating the data itself, it also can act as a part of the security system as well, making sure that certain users and certain systems can or cannot access the data that it needs. Okay. There's two types of database languages that we'll talk about. Now, SQL contains both, but not all database languages contain both. Okay. Now, SQL is the most common, so that's the one we'll talk about. But one is the data definition language. Now, it is the language that is going to be used. It's the keywords and language is going to be used for controlling the structures, the tables, the columns rather, what type of data is in each column, constraints that might exist, things like that. We'll talk about constraints this semester. The data manipulation language is how we actually deal with the data itself, viewing the data, adding new data into our database table, removing data from a database table, modifying. All of these are done using the data manipulation language. Okay. Let's see. Okay. So again, all of these this database access may include a security system, an integrity system, making sure that data, an integrity constraint would be that making sure that there's no duplication in what's called the primary key. We'll talk about that. concurrency, making sure that data stays concurrent. How to describe that? The same data is the same item, if it has a certain value, is going to be the same value across all times that it is used. A recovery control system, this is more like a backup type of situation, right? And then, is my microphone off again? I think microphone may be off. I think my phone maybe. Let me try something. Did I get lost? Okay, I think I'm back. Okay. All right, let's see. Where were we? We'll talk about views. There's a couple of slides here about views early on to kind of give an introduction to views, but I don't want to really cover them here. I would prefer to cover them later, where when we talk more in detail about views. Okay, but basically the idea of views is that it's a subset of the database that allows each user to have his or her own understanding of the database. Again, this is going to be about ways to make sure that users have access to the things they need to, but they don't have access to the things they don't need. So for example, your view of the OBS system is going to be different from my view of the OBS system, right? You are going to see things like your grades and your classes. I'm going to see all the grades for this class, right? So that's going to be a view thing where you don't need to see all the other students' grades for this class. I don't need to see all of your other grades for your other classes, right? And so that's a view approach allows us to be able to define who gets to see what from the database. We'll talk about that later. These are all components of the DBMS environment. Making sure that I'm pointing out not all components are technological components, right? There are the technological components, but there are also people. People are part of a DBMS environment, okay? And not just the programmers, but also the users as well. Okay, so let's talk about those users. So there's a couple of different roles in the database environment. You've got a programmer like the data administrator. They're the ones that are in charge of making sure that the data is correct in the database system. Now, the database administrator, I've not worked in many companies that had a data administrator, but I have worked, I would say every company I've worked for has had a database administrator. Now, this person is usually in charge of the structures as well as the security aspects of the database. Generally, they're the ones that you kind of have to go through them to be able to gain access to something if you need it. And if they're doing their job well, you're probably going to have to convince them. You can't just say, "I need to see this table now," and then they just give it to you. You will probably need to convince them of the why. You'll have to have some reason for why you need access to a certain structure or a certain component. You've also got the designers who will be used for designing, right, the database itself, both the logical and the physical. We'll talk about those phases. You've got the application programmers. Now, that's most of what you've done so far in your coursework at the university. These are the ones who create the user interface as well as what we might call the mid-tier as well. So there's lots of different levels in a database-based system. The application part is how the user interacts with the database, because we don't want them to have to write SQL queries. And then we have end users. End users are involved in the environment as well. All right, so we've got some advantages and disadvantages of the DBMS system. Obviously, the advantages, because this class is all about helping you understand DBMS, there's going to be a lot more advantages than disadvantages, but no such thing as a free lunch. Sometimes we say in American English, the what's sometimes referred to as the Tan-Staffel principle. Oh, is it still not coming through well? I'm sorry, I just noticed that you guys have messaged. Okay. Okay, so some of you seem to be doing okay. Okay, so yeah, no, my phone has been having some issues with connecting, so you may have been hearing some problems there, I shouldn't. Okay, some problems hearing me from my end. All right, so we'll see. What was I saying? Oh, what sometimes we call the Tan-Staffel principle. It's a weird acronym. It's there ain't no such thing as a free lunch. Basically the idea is if you have an organization or a club on campus or something like that that's offering free pizza, usually that pizza is not really free, is it? They are wanting something from you. They're inviting you to come to eat the pizza, but what they want to do is they want to promote their club, or uh, they want to get you to join the club, something like that. They want something from you. Right? And what I'm saying in regards to this is there are a lot of benefits to a database system. There are a lot of benefits to a DBMS, but as we will see in a moment, it's not all free. There are some trade-offs that we'll have to deal with. Okay. But the big ones are going to be stuff like data consistency, meaning that the same value. So for example, a property for rent, the rent price of a property is going to be the same regardless of which component, which system is looking at it, because it's going to get the data from the same place, right? Control of data redundancy. We won't have the same data stored multiple times, right? So we won't be wasting space that way. Let's see, security. That's all the views stuff I was talking about. Let's see, increased productivity, right? Because we're not having to deal with changing the program as well as changing the file structure. If something needs to change like that, we can basically reduce the amount of work to make some simple changes. Okay. There's some of the other ones here, but I won't go into them completely. But I will talk about the disadvantages here, right? Complexity, right? It is more complex, right? There is more to a DBMS than there was to a file system, right? Size can be a problem. Especially for a small database system, for a small database, files might take up less space than the database itself, because there is going to be what we call overhead. There will be some data that will have to take space, some space that will have to be taken on the server in order to house the database itself, even if there wasn't any data. Whereas for a file-based system, if we don't have any data in the files, they don't really take up any space. And so there is going to be a size issue. There's going to be a cost, especially if we go to one of the non-free or non-open source versions of a DBMS, like Oracle, for example. There will be a cost associated with that, and not just cost financially. there can be a cost in terms of time as well. So one of the companies that I worked for, our job was to convert existing data from their system into our version of the database. Right? And there was a time cost involved because while we converted the data, the company had to shut down operations for 3 days. Right? Now that may not seem like a lot, 3 days, but especially for a multi-million-dollar company, 3 days can be a lot of cost to them. Okay, so it needs to be worth it for them to be able to convert into the new system, and that's where this cost of conversion comes into. Okay, and so these are some of the disadvantages, and especially basically big systems, large organizations, especially, quite frankly, things like government-based systems, and this is not a government-based system, particularly to any part of the world. America, Turkey, everywhere is like this. Okay, government systems tend to be what we call resistant to change, meaning that it takes a lot to convince them that they need to change something. Um, I know of friends who have worked in the companies that are like contracting companies with the government, with the American government. Some of their programs are still written in a language called COBOL. If you've ever heard of COBOL, then you know how old that is, right? And some of their programs and some of their systems are still written in a very old language, and it's because those systems are, again, what we call resistant to change, meaning because of the cost involved in changing to a new technology, a lot of times these companies say, "Eh, but if what we have right now is working, why do we need to pay to change it?" Right? Okay, and so that can be a disadvantage, is that there is going to be a cost involved in upgrading to the new version, to the new system, and especially larger, bigger companies may have a hard time justifying the need to pay that cost. Okay, all right. So I do have one more slide about understanding a database system, where we are actually going to look at IMDb, the Internet Movie Database. But because we're so close to that end time, what I'll do is I'll hold this off until tomorrow. Okay, so we will go through this first thing tomorrow morning, and we will analyze a little bit, very, very, not thoroughly, but very loosely analyze the IMDb system. Okay. So are there any questions? Because again, we're almost out of time here, but I do want to open up the opportunity for anyone to have any questions before we close out for today. No. Okay, guys. Well, oh, wait. Okay, yep. All right, Metahan, thank you very much. You too. Also, have a good day. So what I'll do is I'll end the recording here, and again, we will meet tomorrow morning at 10:30, and I will see you then, and we'll jump right into analyzing IMDb.